we're gonna go over the graphing guide. The first thing, which you should already be familiar with, is are you actually doing an experiment or not? In order to do a graph, most of the time, actually, yeah, I'd go ahead and say all the time, you need to be doing an experiment. Okay, just remember that having a hypothesis, having a plan, being scientific, answering a question does not make it an experiment. What makes it an experiment is changing things and comparing things. All right, this is a data chart. This is not a graph. Please don't call it a graph. Okay, there's some good things about data charts, there's some bad things about data charts. A good thing is that it's great for actually collecting your data. Okay, it's very organized. Okay, a bad thing, if you look at this chart in just one little second, it's kind of hard to see a trend or a relationship. So if I just flash you this chart, because of how many numbers are in front of you, you can't just look at it and tell me, oh yeah, enrollment has changed in this way in the past 10 years. Okay, it's a little difficult, it's a little time consuming. Okay, and again, it's a little difficult to make predictions. As opposed to if you have a graph like this, which you can look at in a flash and tell me, yep, that's the enrollment's gone up and it looks like it's probably going to continue to go up. Okay, so that's the big difference between chart and graph. Put that down again. Remember, you can always pause if I'm going a little too fast. Okay, so when you're making a graph, you're always going to be comparing two things called variables. One of those variables is called the independent variable. In your experiment, an independent variable is the thing that the researcher decides to manipulate or change. So in your experiment, the independent variable was what kind of liquid you used. Some people did Coke versus Coke Zero versus seltzer water versus regular water. They decided to change the type of liquid. Okay, the people that did fruit versus Mentos. The type of Mentos was their independent variable. They decided to change that about their experiment, right? This is, of course, in contrast to the dependent variable. The dependent variable is your data that you're collecting. Those are your results. Okay, in your case, that was, man, that was how high your soda fountain went. Okay, I think an easy way to remember the difference between these, there's a few different ways. Dependent is the data. Okay, the reason why it's called dependent is because this variable, the height of your soda fountain, depends upon which type of soda you put excuse me, in your experiment. So the height, you know the soda is going to go higher if you use Coke Zero instead of regular Coke. So the height of the soda is dependent on the type of soda you're using. Okay, another little trick, the independent variable, you can think, I can change this. I, as the scientist, I'm going to decide to change the type of soda. Okay, so I'm changing instead. You cannot change the height of the soda stream directly as the scientist. So that's an easy way to remember too. Okay, when you're making a graph, you're going to put the independent variable on the x and the dependent on the y. So when you make a graph, I want you to look at this for a second and think, What's wrong with this graph? Okay. The first thing, just to let you know, when you make a graph on Excel, it's always going to have these guys called grid lines, and it just is messy and looks ugly. So for me, at least, you don't have to do those. Make them go away so that you can see the nice pretty line. Okay. Now on to what's missing, or some things we should point out. The axes should always display an appropriate range. So notice that down here, these do not cross at 0, 0, right? Imagine if this graph went all the way down to 0 here and all the way to the left to 0 there. This stuff, the information that you are concerned about, the enrollment in the last 10 years, would be this tiny little quadrant up in the top right if this continued all the way to year 0 and this went all the way down to 0 children. Okay, so in science, you don't necessarily have to have this guy be 0, 0. If it makes you feel better, you can make it 0, 0. Go away. I don't want you there. You can make this 0, 0 and then do a little break like that. That one looked kind of bad. But you go like that, you have your 0, 0, and then you make a break. And then that means I skipped a lot of stuff from 0, and now I'm at 40 million. That's probably a more proper way to do it, but this works for me. Okay. Another thing that you have to include, these axes have to be labeled and they have to include the units. So you would write on here number of students enrolled, okay, and you have to tell me what you're talking about. So this is in millions. There's not 44 students enrolled in school in the year 2004. Okay, 44 million. Again, I'm making these numbers up. Okay, so include your units. Over down here, you would put year. Right, the next one, oh, I forget, it goes away. This was number of students in millions. You always put your units in parentheses for, hey, year down there. A good title has to be specific and it has to be descriptive of what's going on in the graph. In your case, a bad title would be my data. Another bad title would be Mentos and Diet Coke reaction. Another bad title would be explosions, exclamation mark. Okay, in English, they teach you, be creative, hook the reader. In this case, no, we're not being creative, we're being descriptive. So the easiest way to do that is to think Y versus X. So a good title for this would be number of students enrolled per year. Or maybe number of students from 2000 to 2012. Or maybe student enrollment per year, but you always want to do Y versus X in some form. Okay. The last thing that you want to have, so that you can see a trend super easily, maybe derive an equation in order to do some predictions, is you want to have a line of best fit going through. Okay. I'm sure some of you have done it in math. You can, if you're writing out the graph, you can do it with a ruler like you do in math, or if you're doing it on Excel, oh my gosh, sorry, that looks really bad. Let's go to the next. There we go. Okay, if you're making the graph on Excel, it'll make the line of best fit for you. Seriously, why does this keep happening? All right. So the three things are label the axis with units, make sure the axes are appropriate, make a title, do a line of best fit if you can, if it's appropriate. Okay. Oh, now we have to go through all of this again. Cool. Okay. So here are 3 groups of examples of different types of data that can be collected. Okay, in Group A, I'll just go with the first bullet for each of them. Group A, we have a school district budget and how much money is allotted to each department. Okay. And in Group B, we have what you just saw, which is how many children have been enrolled in school in the past 10 years. And in Group C, we have how many schools do we have in each state. Okay, along with some other examples here, just to give you some more. So remember, you can pause and look at this for a little bit if you need to. Group A as a whole is comparing divisions of a whole, parts of a whole, percentages, proportions, everything like that. Okay, that's going to be pie chart. All right, Group B is comparing variables over time or over any type of spectrum. So like we talked about today, it could be temperature, it could be pH, or it could be time. So it's not just time, it's over anything that you can put in order. Right? Put in a certain order, something that you're going to want to connect. Okay, that's going to be your line graph. Group C is data that are in distinct groups. So if you look at this, we're looking at schools in different states. We're looking at gas prices at different gas stations. We're looking at a plant grown in the dark versus grown in the light. Okay, so distinct groups or categories, that's going to be a bar graph. Okay, so some pictures so you can see what's going on here. This is going to be your line, bar, and pie. So just to talk about the difference between a line and a bar graph a little bit more, it is possible to make this a bar, okay, that a bar, this a bar, and so on. And it's possible to make this a dot, that a dot, this a dot, and connect these dots. Okay, but look down here at this bar graph. Why would you want to connect Florida and Alabama? And to go a little bit further, why would you want to connect Florida and then Alabama and then Georgia and then South Carolina and then North Carolina? Okay, if you ever run into something like this, you're trying to make a line, or you're trying to think, am I doing a line or a bar? Think, should I be connecting these two things with a line? If not, you want to go for a bar. Okay? So that's what you need to know about graphs. Don't worry about this. What I need you to do, if you haven't already, is I need you to take your first graph that you made on Wednesday. And I need you to take it, and I need you to fix it, make it perfect according to the notes you just took. Okay? Turn that in on Monday.